You can find me on Spotify, R39INALD. You can find me on Twitter at Kanye. And you can find me on Instagram on REGGIECOIN. Today we're talking about Ethereum. What is Ethereum? I'm going to be reading the Ethereum white paper, breaking that down for you. Let's see. Yesterday I went over the Bitcoin white paper, and I figured why don't I just go down coin market cap, starting from the top, working my way down. Now I have to be honest with you, this might be the worst of all of the white paper coverage that I provide because Ethereum is it's complicated and it's also antiquated, right? But why is this important? Um, for two reasons. One, Ethereum, by it being number two right now on the coin market cap, it is a number one alternative to Bitcoin. So if you're thinking about any investing in a new crypto, right? You want to also think about, is this better than Ethereum? Does this do anything that Ethereum already does? How does this compete versus Ethereum? Also, what makes Ethereum different from Bitcoin is that you can create sort of digital apps or tokens on top of Ethereum. So, for example, like typically, most people, if they're going to buy crypto, they're going to go to like Binance, right? Or they're going to go to Coinbase, something of that nature, right? But before a crypto is on a major listing or major exchange, what are the ways to get it? So let's say I just dropped a new crypto. Very often, these new cryptos are being made on top of Ethereum. So there's apps within Ethereum that you connect a wallet into, and then you burn some Ethereum in order to convert that into some other little coin. And if you're just getting in crypto to try to get rich, you may be faced with, dealing with the Ethereum ecosystem at some point. Or you're going to be dealing with cryptos that are competing against Ethereum and the Ethereum ecosystem. So you can't really avoid it. Now, I mentioned that this is going to be the worst for me because, yeah, it's a little complicated for me. Bitcoin is pretty simple. Ethereum is a little bit more complicated, but I'm not, telling you guys you come here, you're gonna learn everything about Ethereum. This is just basically what the heck is Ethereum, right? So, to put it simply, Ethereum is a next generation smart contract and decentralized application platform. So, smart contract, I can say what that is. What is a smart contract? A smart contract is essentially, you can say it's almost like a program that, if this, then that. It might be a little more complicated, but essentially, you can have, agreements where if I send money to a certain wallet, then it's going to automatically convert it to something else, and then send that to another wallet. This would be done with a smart contract. So, what makes Ether special compared to Bitcoin is that if you want to try to do a type of contracting with Bitcoin, you have to have a system where you're sending Bitcoin to something, and then that is externally sending Bitcoin somewhere else. Whereas what's special about Ethereum is that these apps and these smart contracts can be baked literally into the Ethereum ecosystem, right? It builds upon Bitcoin's innovation but extends its capabilities significantly. So let's see, history and background. Let's see, the evolution. So I talked about Bitcoin and the last one. So let's see, the concept of colored coins and metal protocols built on top of Bitcoin. Let's see if we can get to that. Shit, figure out how to get some diagrams, right? Um, so introduces the need for a more flexible, Turing-complete blockchain platform. So it talks about Merkle trees. How is this relevant to you guys at home that are trying to get rich? Um, let's see. This gets into a lot of weeds. So this is why I was worried about doing Ether in the first place, because it gets, geez. Okay. So, let's see. Um, The scripting language as implemented in Bitcoin has several important limitations. Lack of Turing completeness. That is to say, while there is a large subset of computation that the Bitcoin scripting language supports, it does not nearly support everything. The main category that is missing is loops. This is done to avoid infinite loops during transaction verification. Theoretically, it is a surmountable obstacle for script programmers, since any loop can be simulated by simply repeating the underlying code many times with an if statement, but it does lead to scripts that are very space inefficient. For example, implementing an alternative elliptic curve signature algorithm will likely require 256 repeated multiplication rounds, all individually included in the code. What did I just say? But this is one thing that Ethereum says it improves on over Bitcoin. So it's important to know that, okay? Let's see. Value blindness, lack of state, blockchain blindness. Um, so, yeah, I mean, I guess this is just really breaking down all the just because the simplicity of Bitcoin and that you can't really do too much with it. Okay, so now getting into the basics of Ethereum. The intent of Ethereum is to merge together and improve upon the concepts of scripting, altcoins, and on chain meta protocols, and allow developers to create arbitrary consensus based applications that have scalability, standardization, feature completeness, ease of development, and interoperability offered by these different paradigms all at the same time. Ethereum does this by building what is essentially the ultimate abstract foundational layer, a blockchain with a built-in Turing-complete programming language, allowing anyone to write smart contracts and decentralized applications where they can create their own arbitrary rules for ownership, transaction formats, and state transition functions. A bare-bones version of Namecoin can be written in 2 lines of code, and other protocols like currencies and reputational systems can be built in under 20. Smart contracts, cryptographic boxes that contain value and only unlock if certain conditions are met, can also be built on top of our platform, and with vastly more power than that offered by Bitcoin scripting because of the added powers of Turing completeness, value awareness, blockchain awareness, and state. There you go. That's Ethereum for you. Oh no, what am I saying? Let's see what you guys are saying in the chat. BTC and ETH for life for the win. I hear that. Is that the only chat I got? Okay, let's get out of here. Let's see. So Ethereum accounts. So there's externally owned accounts and contract accounts. And then there's gas as a way to pay for computation within the Ethereum network. Gas is important because, as I mentioned in the last video, I believe, gas serves as a transaction cost often. It costs a certain amount of gas to, like, let's say if you're trying to turn some Ethereum into Shiba Inu, you're not just going to get straight Ethereum and then that exact amount into Shiba Inu. You're going to have that value that you want to change, and then the gas, and then after the gas, then that's going to be the output of the Shiba Inu. So yeah, gas is one of these things that Ethereum introduced, and it's important because if the crypto you're investing in is competing against Ethereum, low gas fees are going to be something you're going to see a lot, or it's going to be something that they're going to want to, justify, to compete, because this is a big problem with Ethereum in my time. I don't know. I haven't used Ether recently, but I remember days where the gas would be, you know, 100 times what you're doing. If I wanted to get $25 of Shiba Inu back in the day, if you want to get $25 of Shiba Inu back in the day, the gas fee used to be $25. I'm sure it's not as bad anymore. I pray it's not as bad as anymore. But that's how it used to be. It could probably be worse now. I don't even know. So yeah, Ethereum accounts. In Ethereum, the state is made up of objects called accounts, with each account having a 20-byte address and state transitions being direct transfers of value and information between accounts. An Ethereum account contains 4 fields. The nonce, a counter used to make sure each transaction can only be processed once. The account's current Ether balance, the account's contract code, if present, and the account's storage, empty by default. Ether is the main internal crypto fuel of Ethereum and is used to pay transaction fees. In general, there are 2 types of accounts: externally owned accounts controlled by private keys and contract accounts controlled by their contract code. An externally owned account has no code, and one can send messages from an externally owned account by creating and signing a transaction in a contract account. Every time the contract account receives a message, its code activates, allowing it to read and write internal storage and send other messages or create contracts in turn. Hooey. Let's see. Let's see. Messages and transactions. This is all just like I'm keeping in mind that you're not watching this because you want to build decentralized apps on top of Ethereum, right? You're watching this because you want to get rich from crypto, and I believe in you, so that's why I'm here, to help shepherd you. So what's going on here? Ethereum is complicated, right? So we got some more graphs. We got something called start gas times gas price. I guess these are the calculations for how gas fees are calculated, I think. Code execution. I'm gonna see why people don't read white papers. I've been telling all you guys, you gotta read white papers. You gotta read white papers. I'm here deep into this Ethereum white paper, and I'm lost, kind of. So blockchain and mining. Let's see, where are we there? Yeah, so technical details. Yeah, that's why I fucking lost. All right, so blockchain and mining. The Ethereum blockchain is in many ways similar to the Bitcoin blockchain, although it does have some differences. The main difference between Ethereum and Bitcoin with regard to the blockchain architecture is that, unlike Bitcoin, Ethereum blocks contain a copy of both the transaction list and the most recent state. Aside from that, the other 2 values, the block number and the difficulty, are also stored in the block. The block validation algorithm in Ethereum is as follows. And then they give a lot of rules. So also something worth noting is that I'm not sure how much of this has changed now that Ethereum is proof of stake, right? Or is it all proof of stake? Let's see. Let's ask. Is Ethereum all proof of stake? Yeah, it's a proof of. Yeah, it's all switched. Yeah, it looks like. Okay, which was really good because that's the proof of work is probably the worst thing about Bitcoin. I knew that they introduced proof of stake, just wasn't sure if that was all proof of stake. So it's looking like it's all proof of stake right now. Sorry, doing a little live research. Please hold. Is Ether all proof of stake? Yep, so it's all proof of stake. So a lot of the stuff that I'm reading might not even be relevant anymore. I'm reading the original white paper, right? Oh, well. We'll figure it out. Okay, so back to the white paper. Applications. In general, there are three types of applications on top of Ethereum. The first category is financial applications, providing users with more powerful ways of managing and entering into contracts using their money. This includes subcurrencies, financial derivatives, hedging contracts, savings wallets, wills, and ultimately even some classes of full scale employment contracts. The second category is semi financial applications, where the money is involved, but there's also a heavy non monetary side to what is being done. A perfect example is self enforcing bounties for solutions to computational problems. Finally, there are applications such as online voting and decentralized governance that are not financial at all. Token systems. On blockchain, token systems have many applications, ranging from subcurrencies representing assets such as USD or gold to company stocks, individual tokens representing smart property, secure unforgeable coupons, and even token systems with no ties to conventional value at all, used as point systems for incentivization. I probably pronounced that wrong. Token systems are surprisingly easy to implement in Ethereum. The key point to understand is that all a currency or token system fundamentally is a database with one operation. Subtract X units from A and give X units to B, with the proviso that IX had at least X units before the transaction and 2. The transaction is approved by A. All that it takes to implement a new token system is to implement this logic into a contract. Okay, so now they're going into some math. Okay, financial derivatives and stable value currencies. Financial derivatives are the most common application of a smart contract and one of the simplest to implement in code. The main challenge in implementing financial contracts is that the majority of them require reference to an external price ticker. For example, a very desirable application is a smart contract that hedges against the volatility of Ether or another cryptocurrency with respect to the US dollar. But doing this requires the contract to know what the value of ETH USD is. The simplest way to do this is through a data feed contract maintained by a specific party, such as NASDAQ, designed so that the party has the ability to update the contract as needed and providing an interface that allows other contracts to send a message to that contract and get back a response that provides the price. So then they kind of describe that with some more math. So I'm on page 21 of 36. How much time do we have? We still got some more time. So hello there. Let me look at the chat. What's going on in the chat? Unstake. Okay. Is that the? How do I wish I could see all the messages at a glance. I look like I could just see one at a time. Okay. Whatever. Page 21. There is a lot going on here. So we got to technical details, scalability and concerns, or no, identity and reputation systems. The earliest alternative cryptocurrency of all, Namecoin. I haven't heard the word Namecoin in so long. Attempted to use a Bitcoin-like blockchain could provide a name registration system where users can register their names in a public database alongside other data. The major cited use case is for a DNS system, mapping domains names like bitcoin.org to an IP address. Other use cases include email authentication and potentially more advanced reputation systems. Here's a basic contract to provide a Namecoin-like registration system on Ethereum. So maybe the reason I haven't heard of Namecoin in so long is because Ethereum came out and kicked Namecoin's butt. Decentralized file storage. Over the past year, there has emerged a number of popular online file storage startups, the most prominent being Dropbox, seeking to allow users to upload a backup of their hard drive and have that service store the backup and allow users to access it in exchange for a monthly fee. However, at this point, the file storage market is at times relatively inefficient. Ethereum contracts can allow for the development of a decentralized file storage ecosystem where individuals and users can earn small quantities of money by renting out their own hard drives, and unused space can be used to further drive down the cost of file storage. Is that like, I think I've heard of Filecoin. Then also I've heard of Chia. I don't know if either of those are what this is talking about. The key underpinning piece of such a device will be what we have termed the decentralized Dropbox contract. The contract works as follows. Now they're breaking down a contract for this. Decentralized Autonomous Organizations, DAOs. A generalized concept of a decentralized organization is that of a virtual entity that has a certain set of members or shareholders which perhaps with a 67% majority have the right to spend an entity's funds and modify its code. The members would collectively decide on how the organization should allocate its funds. Let's see. What? So this breaks down how to code decentralized autonomous organization or decentralized organization that's not autonomous or semi-autonomous. So further application, savings wallets. Suppose that Alice wants to keep her funds safe, but is worried that she will lose or someone will hack her private key. She puts Ether into a contract with Bob, a bank, as follows. Alice alone can withdraw a maximum of 1% of the funds per day. Bob alone can withdraw a maximum of 1% of the funds per day, but Alice has the ability to make a transaction with her key shutting off this ability. Alice and Bob together can withdraw anything. Normally 1% per day is enough for Alice, and Alice wants to withdraw more, she can contact Bob for help. If Alice's keys get hacked, she runs to Bob to move the funds to a new contract. If she loses her key, Bob will get the funds out eventually. If Bob turns out to be malicious, then she can turn off his ability to withdraw. This is the wildest hypothetical of all time. Um, I'm wondering what's the fee? Like, okay, so Alice alone can withdraw 1%, but to withdraw that 1%, she's probably got to pay like 10%. So she can't. I don't even know. You know, they're very idealistic about how Ethereum would scale, and I think reality showed that Ethereum did not scale as smoothly as they originally imagined. Crop insurance. Insurance, hypothetically, you could do insurance on a crop using Ether. You want to hear about it? This is so wild. I feel like I've gone to talks and lectures and heard, I heard, Vitalik Burek, whatever, however you pronounce his name. I remember hearing him talk about Ethereum before Ether came out. Remember a lot of talk about Ethereum before it came out and how it's gonna, really change Bitcoin. But I mean, the thing is, everybody said that back then, right? So I feel like I kind of get, I've used a lot of things with Ethereum, so I felt like I got the gist. But have I ever actually sat down and tried to read the Ethereum white paper? I'm not sure. I think I've always felt like it was always too late for me to invest in Ethereum. And it never seemed interesting to me. So, but now I've gone from thinking this is way over my head to now I'm like, yo, this is low key interesting. There's you could do crop insurance on Ethereum. At least it says so in the white paper. So one can easily make a financial derivatives contract, but using a data feed of the weather instead of any price index. If a farmer in Iowa purchases a derivative that pays out inversely based on the precipitation in Iowa, then if there is a drought, the farmer will automatically receive money, and if there is enough rain, the farmer will be happy because their crops will do well. That's crazy. That is crazy. I wonder, I'm interested if that's actually possible. So I'm gonna give myself homework to really look into if you can do crop insurance on Ethereum or more information on crop insurance with Ethereum. Because low key, that's kind of fire. That's the most surprising thing I've seen. Okay, so homework for me. Look at Ethereum crop insurance. Let's see. Decentralized data feed. That's kind of self-explanatory. Smart multi-signature escrow. Cloud computing. Peer-to-peer gambling. Any number of peer-to-peer gambling protocols can be implemented on the Ethereum blockchain. The simplest gambling protocol is actually simply a contract for difference on the next block hash, and more advanced protocols can be built up from there, creating gambling services with near zero fees that have no ability to cheat. Prediction markets. Provided an oracle, prediction markets are also easy to implement, and prediction markets together may prove to be the first mainstream application of Futarchy as a governance protocol for decentralized organizations. And they keep mentioning something called Shilling Coin. Shilling Coin? Never heard of Shilling Coin in my life. On-chain decentralized marketplaces, miscellanea and concerns. I'm on page 26. They're talking about something called Ghost, a greedy heaviest observed subtree. Oh man, I don't know how much this helps you if you're thinking about investing. But here we are. Now, fees. Because every transaction published into the blockchain imposes on the network the cost of needing to download and verify it, there's a need for some regulatory mechanism involving transaction fees to prevent abuse. The Default approach using Bitcoin is to have purely voluntary fees, relying on miners to act as the gatekeepers and set dynamic minimums. It's just boring. Not gonna lie to you. But here we are. I told you had to read white paper. So what am I doing? I'm in here in the weeds, in the white paper, live on camera, confused, interested. Some parts are cool. A lot of it is over my head. And then a lot of it is probably outdated. But here we are. Let's see. We talked about the mistake on here. Turn completeness. Blah blah blah. Currency and issuance. I talk about how much Ether would cost when it's released. And it's distributed. It's supply growth rate, mining, centralization, scalability. Okay, so one common concern about Ethereum is the issue of scalability. Like Bitcoin, Ethereum suffers from the flaw that every transaction needs to be processed by every node in the network. With Bitcoin, the size of the current blockchain rests at about 20 gigabytes, growing about 1 megabytes per hour. Now, this was like over 10 years ago. I wonder where's that at now? If Bitcoin network were to process Visa's 2,000 transactions per second, it would grow by 1 megabyte per 3 seconds. Ethereum is likely to suffer a similar growth pattern, worsened by the fact that there will be many applications on top of the Ethereum blockchain instead of just a currency, as is the case with Bitcoin, but ameliorated by the fact that Ethereum full nodes need to store just the state instead of the entire blockchain history. The problem with such a large blockchain size is centralization risks. If the blockchain size increases to, say, 100 TB, then the likely scenario would be that only a very small number of large businesses would run full nodes. Yada yada. But yeah, I think scalability is, that connects to like why the gas fees are so dang high. So it says I'm at, this is a weird scroll, whatever. But yeah, I remember when I was first going to crypto conferences, this was, maybe 8 years ago. Yeah, scalability is always a big thing. Scalability, and if you're on the outside, if you're new to it, what does scalability mean? Essentially, how well does something grow? So let's say that I'm using a crypto and I'm the only one using it, but then my neighbor's using it also. And then now my whole block is using it. Then the whole neighborhood is using it. This is an example of that crypto scaling. It's scaling across the whole neighborhood. So the problem with a lot of these cryptos is that they will work in theory, and they will continue to work. But the thing is that the more people are using them, the more people mining them, the more sort of different touch points in the system, the more costly it tends to become in terms of data, in terms of electricity, in terms of money. So, yeah, so they have a lot of stuff about the scalability. They try to improve upon Bitcoin's. Let's see. Putting it all together. Decentralized applications. I gotta get out of here soon. The contract mechanism described above allows anyone to build what is essentially a command line application run on a virtual machine that is executed by consensus across the entire network, allowing it to modify a globally accessible state as its hard drive. However, for most people, the command line interface, that is, the transaction sending mechanism, is not sufficiently user friendly to make a decentralization an attractive mainstream alternative. To this end, a complete decentralized application should consist of both low-level business logic components, whether implemented entirely on Ethereum using a combination of Ethereum and other systems, or other systems entirely, and higher-end graphical user interface components. The Ethereum client's design is to serve as a web browser, but includes support for an ETH JavaScript API object, which specializes web pages viewed in the client will be able to use to interact with the Ethereum blockchain. From the point of view of the traditional web, these pages are entirely static content, since the blockchain and other decentralized protocols will serve as a complete replacement for the server for the purpose of handling user-initiated requests. I'm thinking this is like, oh man, what are those called? But I've used a decentralized wallet. You get spammed on Twitter all the time talking about decentralized wallet. MetaMask. Yeah, I think MetaMask is probably a decentralized wallet. Me even saying MetaMask is probably going to get scammers in my comments. So watch out. I have a scammer in my comments says something about MetaMask. Run. Conclusion. The Ethereum protocol was originally conceived as an upgraded version of a cryptocurrency, providing advanced features such as on-blockchain escrow, withdrawal limits, financial contracts, gambling markets, and the like via a highly generalized programming language. And then the rest is notes further. And that's it. We went through the Ethereum white paper. A lot of that was over my head. Not gonna lie to you, I gotta be honest. However, making that attempt, or even having just a little tiny grasp of it, helps. Because when you read about other cryptos, such as Cardano, right? I think Cardano sets itself up to be a competitor to Ethereum. So if you're going to say that, oh yeah, Cardano is better, you should invest in Cardano, I'm going to invest in Cardano, you should at least try to get in there and understand what the heck's going on with Ethereum, right? So yeah, that's what we're doing here. So tomorrow, I'm probably going to go over Tether. And I think Tether is going to be way easier. I'm excited to go over other cryptos. Honestly, I was kind of terrified of going over the Ethereum white paper. I knew it was going to be complicated, but I told myself, yo, Reg, you just got to do it. You got to get through it. You got to go through the shame of people are going to say, this guy doesn't know what he's talking about. And I can be honest. A lot of that was over my head. Some of it I kind of got a grasp of. So I figure, as this channel grows, as my following grows, as I get a million corrections and comments on this, of people telling me how dumb I am. Someday I'm gonna learn from this experience, and someday I'm gonna be able to break down Ethereum even better than today. I promise you that. So thanks for watching. My name is Reginald. I'm on Spotify. R39INALD is Reginald with a 39 instead of EG. I'm on Instagram, REGGIECOIN. I'm on Twitter at Kanye. I like to do live blogs about crypto, so follow me and let's get rich. Bye.